All right, welcome back to Mr. P Helps with Algebra. This is Unit 2, Chapter 3, Lesson number 11. This is a lesson about solving inequalities by graphing them. We're going to start off with a system of equations. We're going to use the elimination method in order to solve for x and y. I'm going to notice, first of all, that the coefficients of the x are exactly the same, so I'm going to subtract. Anything minus itself makes nothing, so that becomes 0. And negative y minus negative y is also 0 because, like I just said, anything minus itself is nothing. Or you can use leave, change, change, and that'd be negative y plus positive y, and those are what we call additive inverses, meaning they add up to 0. 30 minus negative 30 is 60. Now, that is not true. 0 does not equal 60. So in this case, then this means that this has no solutions because these happen to be two lines that are parallel to each other. All right, so for the next question, I'm going to once again look to see what I see, what I notice, and these coefficients are not the same, but these coefficients are the same. Well, they have the same absolute value. So I'm going to add, because they happen to be opposites of each other, inverses of each other. 4x plus 3x makes 7x. These cancel out. That's what makes them additive inverses. And negative 2 plus negative 12 is negative 14. Divide both sides by 7, and that makes the answer for x negative 2. Now that I've got x, I'm going to plug it back into the equation and solve for y. All right, so once I've got that written out, I'm going to combine like terms. 4 times negative 2 is negative 8. Bring down everything else. There's no distributing. I'm going to do opposite operations. Add 8 to both sides. If I add 8 here, it makes nothing. If I add 8 here, it makes 6. Divide both sides by negative 2, division property equality. And that means y must be negative 3. So the answer is negative 2, negative 3. All right, so we're going to get into inequalities now. Oh, wouldn't let me make the negative sign. Okay, try that again. All right, so more things taken out of context in the name of this lesson. Lesson number 11. So we start off with some couple of inequalities, and we're going to graph them like we did with equations by finding the x's and y intercepts. That'd be easier. Now, you could change this to slope-intercept form and then graph that, but I think that's going to be a couple more extra steps. The x-intercept, we know, has a y of 0, has a height of 0. So if this is 0, 45 divided by negative 5 is negative 9. So the x-intercept is negative 9. Come on, there we go. And if the x is 0, that means it's a y-intercept. 45 divided by 3 would be 15. Right there. Okay, so it's going to be a solid line. Looks something like that. And it's going to be everything that is below. So if this line represents everything that's 45, everything below it is the answer. Because the solution has to be less than 45. So that would be that. I'm going to do the same thing for the bottom equation. 24 divided by 2 is 12. So the x-intercept is 12. That would be about right there. And 24 divided by 3 is 8. That would be about right there. A y-intercept of 8. This is going to be a dotted line because it's not or equal to when you look at the inequality. And it's going to be greater. The answer has to be greater than 24. So if the dotted line represents everything that is 24, things that are greater than 24 would be this. All right, so where do the two colors, yellow and blue, intersect? I'm going to make that purple. This is the answer. Everything in this section should meet both of the constraints. Would be both of the answers. So is the point negative 310 a solution? Negative 310, I can almost all but guarantee, I gotta look closely. Negative, is it right on the point? No. So if it's, even if it is right on this point, which is what it looks like, negative 1, 2, 3, yeah. Is it a solution? No, it is not, because the dotted line, the boundary line, is at that point. And so it would not meet the criteria for the blue boundary line. Because the boundary line is not a part of the solution. It would have to be, if you just move it just a smidge this way, now it becomes an answer. But when it's right on that line, it's not an answer. All right, so I did that when I graphed it. I showed exactly how it works. You would do this problem exactly the same. So you do 90 divided by negative 10 is negative 9. Negative 9 would be the x-intercept. Negative 90 divided by 6 would be 15 is the y-intercept. It's or equal to, so it would look like that. And it's going to be shaded below. So it's looking pretty similar to the last one. Okay, and then do the same thing for the other equation. Oh, it looks like it's just times, no, it's not. 36 divided by 6 is 6, x-intercept of 6. And 36 divided by 9 is 4. Dotted line again. Not very straight, but it'll just have to do. And everything that's above it is going to be graphed. I'll do that in blue like I did last time. And although it's not the exact same equation, it's looking very similar. The second equation was a little bit lower than it was the first time, and that purple represents your solutions. Okay, is the point negative 310 a solution? So this time, negative 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like negative 310 this time is a solution, whereas it wasn't on this one, because the dotted line went down just a little bit. So now, if this wasn't an answer, now it is an answer, because now it's right here. It's right in the middle of the purple. All right, so now we're getting graphs, and we're being asked, what would the equations be? What would the inequalities be? Sorry, so notice that this triangle here, that there's, first of all, there's 3 boundary lines. There's one like this, there's one like that, and there's one going down like this. So let's start off with this, the inequality here. So first of all, it hits at 10, and it looks like it's going up 1, 2, right 1. No, it's not. No, it's up 1, 2, 3, right 2. Up 3, right 2. It's going up 3, right 2, up 1, 2, 3, right 1, 2. Yep, perfect. And the line is solid, which means it's or equal to, and it's graphed below that line. This part is below this boundary line. So I'm going to do the same thing now for this line. This line is also starting at 10, but this time it's going down 2, right 1, down 2. No, that's not quite it. Gotta look a little closer. 1, 2, 3, right 1. No. 1, 2, 3, 4, 5, 1, 2. Okay, so it's down 5, right 2. And it is also below the line, and it is solid. This line right here, the shaded part is below that line. Last one, which is this line right here. It looks like it's hitting at 3. If I'm not, nope, that's 2. So it looks like it's hitting at 2, and it's going up 1 for every right. 1, 2, 3, 4, 5, 6. So, I almost called that one. So that's up 1, right 6, like that. And y this time has to be greater than, because the shaded part is above that boundary line. The boundary line is going up 1 for every right 6, and it is starting at positive 2. Now this one down here, this one does not have a solution, because this purple part right here would meet this answer. It would be to the right or above this line. It could also say it's above this line, and you would say it's above this line. But none of the other portions meet that same criteria, whereas this would be to the right of this line. That's good, but it's not to that side. It would be to the other side. So none of these, there's no way to make a graph. System of inequalities have all 3 of these places meet all 3 of the constraints. It's just simply not possible. All right, so that was the next card. Due to the time, I'm going to skip past that and get to the homework. Tatiana makes $8 per hour. I'm going to say X is the amount of hours lawn mowing, plus $12 babysitting. So that's going to represent the per hour babysitting. How many hours babysitting? She wants to make at least $96. So that would look like this. But she can work no more than 12 hours a week, so which means if you add up all her hours, she cannot work no more than, so it can be 12. So it'll look like that. Write a graph for system of equalities. Okay, so we're ready. So let's find the x and y intercepts of each. 96 divided by 8 is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 right there. 96 divided by 12 is 8. 1, 2, 3, 4, 5, 6, 7, 8 right there. It's a solid line because it's or equal to, not so straight. It's graphed on top because it's greater than. Looks like I chose purple. That'll just have to do. 12 divided by 1 is 12, which is right here again. 12. Well, that was 8, 9, 10, 11, 12 right there. It's also going to be a solid line, but it's going to be shaded below. So I'm going to shade below like such. And what you're going to notice is the only place that these two graphs intersect is right here. So red is my solution set. This little triangular piece. Sorry, I can't be a little bit more precise. Yes, you do need to be precise when doing this. If you've got straight lines, that would make it even better. The red line is the solution. Okay, so that looks like that's about it. Please give it a like if it helped you learn something about inequalities, and subscribe if you haven't done so already. Have a wonderful day.